Hi, I'm Woo-Sung Ko, also known as Rice. Today I'll be presenting our work, Scalable Auto-Feedback for LLM-based chart generation on behalf of the authors listed here. To provide a brief overview, our work addresses the challenge of data scarcity and high curation cost in chart generation, which in turn results in poor quality generations. To solve this problem, we propose C-squared, a scalable framework that combines ChartAF, a reference-free feedback provider, and ChartUIE-8K, a diverse dataset enhancing generalization and aligning closely with real-world charting needs. Let's start with our motivation. Many of us use LMs to generate charts from data by providing natural language instructions. Despite rapid advancements, chart generation remains a major challenge. Beyond code execution errors, generated charts often fail to follow instructions and may be barely legible, as illustrated on screen. So why might the progress of LM-based chart generation be slow? A key challenge is the lack of instruction data code triplets for training, unlike image generation where labeled data is abundant. When input-output pairs aren't readily available, we could use human curators to create fine-tuning data. However, curating instruction code pairs requires both technical and artistic expertise, making it significantly more expensive than simple image labeling. Ultimately, data scarcity and the high curation cost form the principal bottleneck in advancing LM-based chart generation. Instead of curating additional fine-tuning data, one alternative is to improve generations via feedback. Feedback can be incorporated in various ways. Parameter updating approaches are available in the likes of RLHF and DPO, or inference time methods such as best of n decoding and in-context feedback for regeneration. However, the scalability of these approaches depend critically on the cost of verification. The most straightforward approach would be using a human verifier, but its high-cost nature leads us to the same scalability problem. Fortunately for domains like mathematics, cheap rule-based verifiers are available, but this is not the case for chart generation. So we turn to VLM-based AI verifiers. Numerous existing works use VLMs as chart generation verifiers. However, these methods perform well only under a reference-based regime, meaning they require a gold reference. These methods essentially function as similarity evaluators. Since these gold references require human curation, we're back to the same scalability problem we started with. Concretely, these verifiers only work well given the instruction, data, and corresponding ground truth code or image. To overcome the fundamental limitations of reference-based verification, we propose a novel solution, chart auto-feedback, or ChartAF for short. Figure 1 on the right provides a high-level schematic overview. First, the model generates an initial chart, then ChartAF verifies it and provides feedback to refine the final output. Once we achieve reference-free verification, we can curate a diverse, large-scale evaluation set, ChartUIE, without requiring ground truth images or code. Together, ChartAF, our reference-free feedback provider, and ChartUIE, a large-scale chart generation instruction dataset, comprises C-squared, our overarching framework. ChartAF is primarily an agentic pipeline that is realized through prompting. As seen in the top left of the figure, we begin with the user query, which is used interchangeably with the term instruction throughout this talk. The dashed containers show qualitative examples. This user instruction is sent to both chart generating LM and ChartAF. Let's examine ChartAF's pipeline in detail. First, the instruction is decomposed into task, purpose, and audience. For instance, the task of this instruction is to visualize the distribution and outlier. Then these decomposed factors are combined with the basic criteria to generate the query-specific criteria. The basic criteria is a universal standard applicable to any chart. Next, we transform the query-specific criteria into binary questions. For example, does the chart effectively highlight significant outliers in stress levels during sleep? If the verification only requires a scalar value, the process is terminated, and this is the entire chart AF-S. However, if granular natural language-based feedback is required, we transform this evaluated binarized criteria into direct language-based feedback. We classify each criterion into one of 4 categories: retain, edit, discard, and add, and prompt the verifier to provide code-centric feedback. For instance, edit, modify the box plot to use different colors for each sleep stage group. Complete with specific before and after code suggestions. Now that we have an effective reference-free verifier, we attempt to evaluate our verifier on a wide range of chart generation tasks. Previous evaluations have been severely constrained, limited to at most 132 queries, 25 underlying datasets, and 33 chart types. This limited diversity stems directly from the expensive human curation required for reference-based evaluation. In stark contrast, our chart UIE dataset embodies a variety of queries, underlying datasets, chart topics, and types. We crawl datasets used for data visualization and filter for appropriate licenses. Finally, we leverage GPT-4o as a user emulator to generate queries with diverse and appropriate chart types and annotations. Since we are evaluating an evaluation system, our studies are human-centric. We conduct 4 human studies. 1. Chart AF scalar scoring ability. 2. Whether its natural language feedback improves charts. 3. Comparing chart UIE instruction length to real LLM user instructions. And 4. Whether users find chart UIE realistic and preferable to existing datasets. We examine whether chart AF scalar scores are useful through best event test time scaling. We generate N outputs, score them with chart AF, then select the highest scored one as the final output. As shown in the figure on the left, increasing the inference generation budget consistently leads to higher average and median final output scores. But does this score improvement actually translate to better charts? To answer this, we do a human preference survey from strongly prefer pre-test time scaling all the way to strongly prefer post-test time scaling. Each participating surveyor is provided a random sample. The results were definitive. 74% of respondents strongly preferred charts generated with post-test time scaling using chart AF feedback. Next, we evaluate the utility of chart AF's granular natural language feedback. We use the same preference scale as before. -2 represents strongly prefer pre-feedback, while +2 represents strongly prefer post-feedback. We represent the mean value as mu and median value as tilde mu. For comparison, our baselines include ChatEval, a general LM evaluator, and 4 chart domain-specific verifiers. Since language-based evaluation can be viewed as a reasoning task, we also implement auto chain-of-thought prompting and self-consistency decoding for a more comprehensive comparison. Despite processing 14 to 15,000 tokens per evaluation, our approach costs only about 10 cents per chart, making it economically viable for large-scale deployment. Finally, we empirically validate whether our chart UIE is both realistic and useful. First, we gathered ground truth data by asking day-to-day LLM users to provide chart generation instructions. The word count distribution of real user instructions is shown in purple in figure 6. As you can see, compared to existing instruction datasets, chart UIE's distribution is significantly closer to this ground truth distribution. We then conduct a direct evaluation where LLM users assess randomly sampled chart UIE instructions against existing alternatives. The results were solid. Users found chart UIE instructions more preferable 94% and realistic 93% of the time. Thanks for tuning in to our talk. Feel free to reach out to us in person at the conference or drop us an email. Also, our project site visualizes an extensive list of qualitative examples, so feel free to check that out as well.